In this video, we solve a system of 3 linear equations with 3 unknowns. Although the substitution method is always applicable, the elimination method is most effective for larger systems. So again, usually the substitution method is reserved for smaller systems of equations, such as only 2, whereas methods with matrix math and the elimination method is reserved for larger systems of equations. So the first step is apply the elimination method to any combination of equations. I always love to eliminate z first because it just seems less intimidating. That's how I approach it. I always eliminate z because then I have equations in terms of x and y only. In this case in particular, yeah, it's also great to eliminate whatever seems easiest. So this is a double whammy. Z is definitely easiest to get rid of. So I will do simply equation 1 plus equation 2. So if I do this, 1 plus 2 notice how we get 3x plus x gives me 4x plus y. Z's eliminate, and I'm left with negative 14. I box this result and I label it equation 4. Good. Next we do, perfect. So step 2 is we repeat the same process and we apply the elimination method to any other combination. That looks messy. Hold on one second. Any other combination of equations. So we could do, let's combine 1 and 3. So if I do equation 1 plus equation 3, well, let's try canceling. Oh, and it has to be any other combination of equations such that we cancel z again. So if I want to cancel z again, I'd have to do 2 times equation 1 plus equation 3. So I want to cancel the same variable again, and we'll see why. So 2 times equation 1 would be 6x minus 2y plus 2z equals negative 30. Then we have equation 3, 2x plus 3y minus 2z equals 0. This gives 8x plus y. Notice how z's eliminate again. A positive 2z minus 2z, and this equals negative 30. I box this equation and I call it equation 5. Almost done. Now look what we did. When we eliminated z, we just created a system of two equations with two unknowns. They're only in terms of both x and y. So now we repeat the process again. We apply the elimination method to equations 4 and 5, and we can solve. So let's repeat this. So step 3, apply elimination method always to equations 4 and 5. Because they're only expressed in terms of x and y. So let's see, if we add equation 4 plus equation 5, let's see, we can eliminate, let's try to eliminate y. So I'd have to do negative times equation 4. You may have to look back if you're writing this down. If we do negative 1 times equation 4, we'll get a negative y. So let's do that. So that'll give us negative 4x minus y equals the positive 14. And equation 5 is still 8x plus y equals negative 30. Four x, y's cancel, equals negative 16. Finally, we solve for x, and it's negative 4. Step 4, we must plug the first number we find always into equation 4 or 5. Why is this? Well, remember 1, 2, and 3 contain z. So we would still have two unknowns. We don't know y, we don't know z. But if we plug it into 4 or 5, well, those only have x and y. So let's plug it into, I don't know, let's plug it into equation 4. That will be, equation 4 was 4 times x, which is now negative 4, plus y equals negative 14. So negative 16 plus y equals negative 14. So y equals 2. Good. Finally, can you see what the last step would be? They logically follow. Step 5 would be, well, we have x and y. We need to find z. So now we're not looking at equations 4 or 5 anymore. We have to plug our x equals negative 4 and our y equals 2 into one of the original 3 equations, 1, 2, or 3, because they contain z. This would allow us to solve for z. So let's plug them into equation, let's see, I did equation 1. Go back to equation 1. That was 3 times x, which is negative 4, minus y, plus z equals to negative 15. Let's see, that's negative 12 minus 2, so that's negative 14 plus z. So I add 14 to both sides, and I get z equals negative 1. So that's a step-by-step procedure and a very organized method on how to solve a system of 3 equations, 3 unknowns. I love a process. I love a procedure. I do memorize it as like a step-by-step process, but it's so logical that I understand what I'm doing. So I highly suggest labeling the equations this way and applying this method.